So today's topic is assignment model. In an assignment model, there are 5 concepts. First is balanced problem, second is unbalanced problem, then minimization, maximization, and restricted problem. Done? So we will see these 5 concepts on the basis of numerical. Numerical means managerial problem. Clear? I am not explaining one by one all balanced problem, unbalanced. You will see how we can identify the problem is balanced or unbalanced. How we can identify the problem is associated with minimization or maximization. So we have first case. In this one taxi company, Joy Taxi. Joy Taxi has 4 taxis. Name 1, 2, 3, 4. And there are 4 customers A, B, C, D. Requires taxis. The distance between the taxis and the customers are given in the table in kilometers. The taxi company wishes to assign the taxis to customers so that distance travel is optimum. Optimum, what is optimum? Any idea? Anyone? What is optimum? Okay. So this is the case of taxi company. And we have distance between different taxi points and customers. Clear? Suppose a company and 4 taxis, first, second, third, fourth, and these are 4 customers. So different location for taxis and different locations for customer. Clear? Now company wants to minimize the cost, and minimization of cost is based on minimization of distance. Clear? So in this case, main objective is what? Minimization of distance. So we have different taxis 1, 2, 3, 4. These are, we can say, these different locations also, and these 4 customers. So this is first taxi. From location of first taxi, the customer distance is what? 120 kilometers. And second customer distance is what? 100 kilometers. Clear? So these are what? Distances. Now once again we will read this question. So Joy Taxis has 4 taxis 1, 2, 3. There are 4 customers A, B, C, D. The distance between taxis and customers are given in the table in kilometers. So these are what? These are distance between taxi points and customers. Just like Ola cabs, different locations of Ola cabs and different locations of customers. So in that situation, in case of Ola or Uber, you will get the taxi which is nearest to your place. Clear? This is what? Minimization of distance. Minimization of distance means minimization of fuel utility. This means minimization of cost. Done? Okay, so the taxi company wishes to assign the taxis to customers so that distance travel is optimum. Now, the main task is what? We need to allocate taxis, different taxis to different customers to minimize distance. Clear? Done? So, as there is problem associated with distance. So, in business organization, just like in Ola or Uber, distance should be minimum or maximum? Distance of customer from the taxi should be minimum or maximum? Minimum. Clear? Profit of the company should be minimum or maximum? Revenue of the company should be maximum or minimum? Maximum. Okay. So we will decide this problem is associated with minimum or maximum on the basis of the given data set. This data is associated with distance. Distance should be minimum. If this data is associated with profit, then this is maximization problem. Is this data is associated with cost? Cost should be minimum. If this is associated with time, time should be maximum or minimum? Time should be minimum. Clear? So this problem is associated with minimum. This problem is associated with minimization. Clear? So in exam, you may have word minimum also in place of optimum. You may have word like maximum also in place of optimum. Clear? Done? Okay. So difference between minimization problem and maximization problem, I think clear. If the words associated with maximization, then problem is of maximization. If the word associated with minimization, then problem is of minimization. So this problem is of minimization. Okay. Second thing, how many taxis are there? How many customers are there? 4. This means number of taxis, number of customers are equal. This means your problem is balanced. This means you need to allocate one taxi to one customer or one customer to one taxi. No remaining customer, no remaining taxis. Is it clear? Done? Okay. So in this case, this is what? Balance problem. Because number of rows, we can say number of rows equals to number of columns, or we can say number of taxis equals to number of customers. Is it clear? So we will start assignment problem with first step, problem is balanced or not. What? Problem is balanced or not. Okay, so we are writing first heading in this case, is it balanced? So your answer is what for this? Your answer is yes, because reason is what? Yes, because number of rows equals to number of columns. This is the first point in all assignment problems. Is it clear? Now, next point is what? Is it minimization? So your answer is what? Your answer is again yes. Reason is what? Because data is associated with distance and distance should be minimum, and distance should be minimum. So this problem is balanced and this problem is of minimization. Done? Now third thing, now we will solve this problem. Now method to solve this problem is known as Hungarian method. The name of this method is what? Hungarian method. So now we are working for Hungarian method. So this is Hungarian method and first step. First step name is row minimum. Row minimum. So in first row, not only in first row, we will see in all rows minimum number. Okay, so in first row the minimum number is 80. So we will subtract all the elements of this row. We will subtract this 80 from all element of this row. This means 120 minus 80, and this 100 minus 80, this 80 minus 80, and this 90 minus 80. So first we will write what? First we will write 120 minus 80, that is what? 40. This is 120 and least number of this row is 80. So this 120 minus 80 is 40. Next 100 minus 80 is 20 and 80 minus 80 is 0 and 90 minus 80 is what? 10. So this is from first row. Now from second row. In second row least number is what? 70. So 80 minus 70, that is what? 10. And then next number is this 90. 90 minus 70 is 20. Then next is 110. 110 minus 70 is 40 and 70 minus 70 is 0. And from third row, in third row the least number is 110. This is 110. Now we will subtract this 110 from all the elements of this third row. So this, this is not 110, this is 100. The least number is 100. So we will subtract this 100 from all elements of this third row. So 110 minus 100 is what? 10. And then 140 minus 100 is 40. And then 120 minus 100 is 20. And this 100 minus 100, that is what? 0. Now next, in next row, the least number is 80. So we will subtract this 80 from all element of this fourth row. So this is 90 minus 80 is 10. Then second also 90, again 10. And this is 80 minus 80 is 0. And this 90 minus 80 is 10. So this is what? This step is known as row minimum. Now we will do this same thing for column. And the name of this step is what? Column minimum. Clear? Okay. So resultant table of this first step is this. Now we will apply this second step on the resultant of step first. So in first column, the least number is what? 10. So we will subtract this 10 from all these number of first column. So this 40 minus 10 is 30, and this 10 minus 10 is 0, this 10 minus 10 is 0, this 10 minus 10 is 0. Now next is, in next column again 10 is least number. So we will subtract this 10 from all the elements of column B. So this become what? 20 minus 10 is 10, this 20 minus 10 is 10, this 40 minus 10 is 30, and this 10 minus 10 is 0. Now in third, 0 is the least number, so no need to subtract, because if you will subtract 0, then you will get same quantity. So we will write same column, no change, 0, 40, 20, 0. And in last column, again 0 is least number, so we will not subtract this 0. We will write same column, 10, 0, 0 and 10. So this is column minimum. And the objective of these row minimum and column minimum is what? The objective is to find at least one 0 in all rows and in all column. So after completion of this step, you will see at least one 0 in all rows and in all columns. Now step third. In step third, we will copy this same table of step 2, column minimum. So for this step third, allocation of assignment, I have copied this same table as it is, no change in this table. Now this is very important step. So in this step, allocation of assignment, and assignment is denoted by square. Assignment is denoted by square. And so we will see the row which has only 0. We will see row or column which has only 0. So first we will see in row. If there is no single 0 row, then we will search single 0 column. Okay, so we will see from top. In first row, we have single 0. If there are two zeros in this first row, then we will select another row which has single 0. So by default in this case, you have single 0 in first row. So you will put box on that 0, and this box is considered as what? Assignment. So you will put box on 0 of single 0 row, and then cut the other zeros of corresponding column. You will cut the other zeros of corresponding column. Listen once again. So first we will search single 0 row, by default this first one, and then we will put box on that and cut the other zeros of corresponding column. So in this column only one 0 is there. So we will cancel out this 0 by cross, only cross. And then now in remaining table, in remaining table again we will search single zero row. So first already done. Now in second row we have 2 zeros, so we can't select this second row. Now in third row we have 2 zeros, so again we can't select this third row. And in fourth row, now the remaining number of zeros are 2 because 1 is cancelled and 2 are there. Clear? So we will not consider this third row also. Now the another option is what? If we don't have single zero row, then we will search single zero column. So we will search from first column. So in first column there are 3 zeros, so we will not select this first column. Now in second column we have only 1 zero. So we will put box on that 0. Of second column we have single zero column. In this single zero column we will put box on that 0. And then this is the selection from column. That's why we can cancel out the zeros of corresponding row. If we are selecting this box from row, then we will cancel out 0 of corresponding column. If we are selecting this box on the basis of column, then we will cancel out other zeros of corresponding row. If column, then row. If row, then column. Now again single zero row. So in first row no single zero, 2 zeros are there. Now in third row no single zero, again 2 zeros. Now we will see in column. In first column 2 zeros, in second column no zero, in third column no zero, and in fourth column no zeros. This means equalization. In that situation you don't have single zero row. In that situation you don't have single zero row. So you will put box on any zero of your choice. You can put box on that 0, or on that 0, or on that 0. Only one. So I am putting box on this one. Okay. So this is from row also, this is from column also. So we will cancel out zeros of corresponding row as well as column. So first we will select single zero row. If no single zero row, then we will search in column single zero row. If no single zero row, no single zero column, then in that situation we will select any zero and put the box on that, and then cut the other zeros of corresponding row and column. And now you will see only 1 0. Now in whole table you have only 1 0. You can consider from table, from row or from column, doesn't matter. So now you will put box on this single zero. Now no other zero is left. All the zeros are covered by either box assignment or by cross. So this is what? This is allocation of assignment. Now next step, we will put all these allocations in original table. So in this step we have this original table. Now we will put box in original values. So this first box for first row C column. So first row C column means for this 80, and then second row first column this 80, and next is third row fourth column this 100, and then this fourth row and second column this 90. So these are the allocations. Now we can say the taxi 1 is allocated to customer C, taxi 2 is allocated to customer A, and taxi 3 allocated to customer D, and taxi 4 allocated to customer B. Done? And now we will put all these values in final table. So in final table, this is taxi column, this is customer column, and this is distance. So first, taxi first, taxi second, taxi third, and taxi fourth. Okay. So allocation for taxi first, which customer? Customer C. And for second taxi, customer A. And for third taxi, customer D, and for fourth taxi, customer B. And then distance. So first distance is this 80. So this first distance is 80. Second distance is again 80, and third distance is 100, and then fourth distance is what? 90. Now we will find total distance. So total distance for this case is 350. So this is total distance, and we can say this is minimum distance, minimum total distance, minimum total distance. Or we can say this as optimal distance also. This is also known as optimum or optimal distance, optimum distance. So this is overall assignment unbalanced problem, and this is very simple case. In next case, we will see concept of line. When we have a little bit critical problem, then you can't solve directly only by cross and box. You need to apply line step. So in next lecture, we will see line step. So I hope you understand this concept. So please like my video and subscribe my channel Ganit Coach. Have a nice day.